Welcome back. Today's topic is suspension and colloids. Start with suspension. We have studied that substances which are soluble in water form solutions, but those substances which are insoluble in water form suspensions. A suspension is a heterogeneous mixture in which the small particles of a solid are spread throughout a liquid without dissolving it. Some common examples of suspensions are chalk water mixture, muddy water, milk of magnesia, sand particles suspended in water, flour in water, etc. Chalk water mixture is a suspension of fine chalk particles in water. Muddy water is a suspension of soil particles in water. And milk of magnesia is a suspension of magnesium hydroxide in water. The solid particles and water remain separate in a suspension. The particles do not dissolve in water. We will now study the properties of a suspension. If we shake some chalk powder with water in a beaker, a milky suspension is formed. We can see fine particles of chalk suspended throughout the water without dissolving in it. If this suspension of chalk and water is kept undisturbed for some time, what will happen? The chalk particle settle down at the bottom of the beaker. This means that chalk and water suspension is unstable. If we filter the suspension of chalk and water, the chalk particles are left behind as a residue on the filter paper and the clear water is obtained as a filtrate. This means that chalk and water suspension can be separated into chalk and water by filtration. If a beam of light is passed through chalk and water suspension, it scatters the beam of light and so the path of light is visible in the suspension. So we can conclude the properties of suspension. First one, suspension is a heterogeneous mixture. Second one, the size of the solute particle in a suspension is quite large. The particles of a suspension can be seen by the naked eye. The particles of a suspension scatter a beam of light passing through it and make its path visible. Next one, the solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from the mixture by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. Next we can study about colloids or colloidal solutions. A colloid is a kind of solution in which the size of the solute particle is intermediate between those in true solutions and those in suspensions. The particles of a colloid are uniformly spread throughout the solution. The size of the solute particle in a colloid is bigger than that of true solution but smaller than that of suspension. Due to relatively smaller size of the particle as compared to that of suspension, the mixture appears to be homogeneous. But actually, a colloidal solution is a heterogeneous mixture. Some examples of colloids are soap solution, starch solution, milk, ink, blood, jelly, solutions of synthetic detergents, etc. If we shake some soap powder with water in a beaker, we get a colloidal soap solution which is not perfectly transparent. The soap particle cannot be seen by us. If the soap solution is kept for some time, the soap particles do not settle down. If we filter the soap solution, the whole solution passes through the filter paper and no residue is left behind, showing that it cannot be separated by filtration. All these observations indicate that soap and water mixture is a true solution. The scattering of light by soap solution and examination of soap solution under a high power microscope shows that the soap solution is not a true solution. In a true solution like sugar solution, the solute particles are so small that they cannot scatter light rays falling on them. For example, if a beam of light is put on a true solution, say sugar solution, kept in a beaker in a dark room, the path of a light beam is invisible inside the solution when seen from the side. The beam of light can become visible only when the solute particles are big enough to reflect light falling on them. Since the particles of true solution do not scatter light, we conclude that they must be very small. In a colloidal solution, the particles are big enough to scatter light. This can be shown as follows. If a beam of light is allowed to fall on colloidal solution kept in a beaker in a dark room, the path of light beam is illuminated and become visible when seen from outside. The path of light beams become visible because the colloidal particles are big enough to scatter light falling on them in all directions. This scattered light enters our eyes and we are able to see the path of light beam. The scattering of light by colloidal particles is known as Tyndall effect. The scattering of light by the colloidal solution tells us that the colloidal particles are much bigger than the particles of true solutions, and hence colloidal solutions are not true solutions. So, a true solution can be distinguished from a colloidal solution by the fact that a true solution does not scatter a beam of light passing through it, but a colloidal solution scatter a beam of light passing through it and render its path visible. In other words, a true solution does not show Tyndall effect, but a colloidal solution shows Tyndall effect. Tyndall effect can also be observed when fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. The Tyndall effect can be observed when sunlight passes through the canopy of dense forest. In the forest, mist contains tiny droplets of water which acts as a particle of colloid dispersed in air. The particles of some colloidal solutions can be seen through a high power microscope. For example, if a drop of milk is examined under microscope, we can see the particles of fat floating in the liquid. This observation shows that colloids are heterogeneous in nature, though they appear to be homogeneous. Now we can conclude the properties of colloids. First one, a colloid is a heterogeneous mixture. The size of particles in a colloid is bigger than those in a true solution but smaller than those in a suspension. It is in between 1 nanometer or 100 nanometer in diameter. The particles of colloidal solutions cannot be seen with our naked eyes. Colloids are big enough to scatter a beam of light passing through it and make its path visible. They do not settle down when left undisturbed. That is, a colloid is quite stable. They cannot be separated from the mixture by the process of filtration. But a special technique of separation known as centrifugation can be used to separate the colloidal particles. These are the properties of colloidal solutions. The components of a colloidal solutions are the dispersed phase and the dispersion medium. The solute-like component or the dispersed particle in a colloid forms the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersing medium. Colloids are classified according to the state of the dispersing medium and the dispersed phase. The classifications are aerosol, foam, emulsion, sol, foam, gel and solid sol. First one, aerosol. An aerosol is a colloid in which a solid or liquid is dispersed in a gas. The examples of aerosols in which liquid is dispersed in a gas are hairspray, fog, mist and clouds. The example of aerosol in which a solid is dispersed in a gas are smoke and automobile exhaust. Next one, foam. The foam is a colloid in which a gas is dispersed in a liquid medium. The example of foam are fire extinguisher foam, soap bubbles, shaving cream and beer foam. Next one, emulsion. An emulsion is a colloid in which minute droplets of one liquid are dispersed in another liquid which is not miscible with it. Example of emulsions are milk, butter and face cream. Sol. Sol is a colloid in which tiny solid particles are dispersed in a liquid medium. Examples of sol are milk of magnesia, mud, ink, soap solution, starch solution and moist paint. Next one, solid form or simply form. The solid form is a colloid in which a gas is dispersed in a solid medium. The examples of solid forms are foam, rubber, sponge, pumice stone, bread, etc. Next one, gel. Gel is a colloid in which liquid is dispersed in solid medium. For example, jelly, cheese, butter, gelatin, etc. Last one is solid sol. Solid sol is a colloid in which solid particles are dispersed in a solid medium. The example of solid sol is colored gemstone like ruby and milky glass. That's all about suspension and colloids. Hope you understand everything. Thank you for watching.